Hello all, welcome back to my channel. This is Babu Krishna. So now let us continue with our discussion on the operators. So last time we have seen the operators, assignment operator, and then the arithmetic operator, then relational, and then Boolean or logical or Boolean operator we have seen. Now it is time for us to check on the bitwise operator. So same bitwise operator, what we are doing now, going to do now will be the same in any other programming language, but it is rarely used in the shell scripting. So this, if you want to skip, you can, but it will be, if you see this particular discussion, then you will be able to understand well the bitwise operators actually. So that is yeah, so this is useful. The same thing you can work on the any other programming language. So here we'll first see the discussion, and then we will go with the uh, executing the program. Okay, so now once we have opened that, and let us open the um, contents. So we have seen whatever the yeah, logical Boolean operators, and yeah, we'll see that. Okay, now let us check on that the bitwise operators. So yeah, bitwise operators. Before we go to the bitwise operators, these are the bitwise operators like and or and exclusive or, and then negation, and then you have the left shift, and then you have the right shift. These are the operators for the bitwise. So before we go to the bitwise, we need conversions actually. So that is very important, because in the when we see the bitwise operators, you need conversions. So let us check on the conversions, then we go to the bitwise operators. So conversions is like you can represent the binary, like whatever we see the number, it is a decimal, but we can have also any other radix actually. So like binary, octal, decimal, hexadecimal, and all. So if you take Python, it will support all that, even including 36 radix. But here in the shell scripting, it will be enough with the octal and decimal and hexadecimal. Binary I'm not like no not discussing, because I don't want to confuse you, and then it will not be supported. This one we need to write our own thing to support it. So that's what I am ignoring as of now. So we have three types which we will see: octal, and then decimal, and then hexadecimal. So if is telling you the binary also, you can binary you can easily see with octal, the same thing you can do, but you cannot print or echo in the shell script. You need to write your own functions to implement that. So then that will be little like it may little look complex for you. So let us only try this actually, then we will you can check on that how to do that particular one. Okay, so now we will see this whatever the decimal number actually. So let us assume I have a decimal number, and now let us any number actually. So maybe I will take 123 as in slides. This is a decimal number. Now I want to convert this particular decimal number to octal. How I will do actually? So now I want equivalent in the octal. So how I will do? So like whenever you take any decimal number, you need to do in the octal actually. So what you will do, you need to divide by 8. So I will say whatever I have 123, I need to divide by 8 actually. So 8 1 is 8, 4 3 8 5 is 40, and then remainder is 8 actually. So one remainder is 8, 8 1 is 8, uh, 4 3 8 5 is 43, remainder is 3. So now again we divide by 8, then it will give you 8 1 is 8, and then remainder. So I am writing the quotient here, then remainder actually. So 8 15 is 120, remainder 3, 8 1 is 8, 7, remainder 3, and you need to go from down to up actually. So that's what, like no 173 3, this is octal. Okay, so this is octal. So 123 decimal, now you can represent the same thing with 173 in the octal. Now I want to have whatever like octal to decimal. Let us assume I want to take the same octal value to decimal. What you will do actually? So octal to decimal, you need to multiply by 8. So now let us assume we take the same octal value 173, and we will do this. So you need to multiply by 8 actually. Okay, so multiply by 8 and then power. So this is 8 power. I am representing double, like for our convenience, this is double star is for power actually. So now you need to multiply, uh, yeah, like this, and then this particular 2, uh, 8 power 2. So if you observe that, we are starting with from the right side actually. Okay, so you are multiplying but 8 power 0, 8 power 1, 8 power 2, and then you are adding everything actually. So you are adding all these three things actually. So what it is now, 8 to the 64 plus 8 7 ja 56, and then 8 to power of 0 is 1, and then 3. So it will become whatever 7, mm, 9, 9 plus 4, 13, and then 11, 12. So 123, which is nothing but decimal 123, which is right because we already converted that, and which is right actually. So octal to decimal, decimal to octal, you will do like this. So decimal to binary, if you want to do, you need to divide by 2, and binary to decimal you want to do multiply by 2. Simple. So now we will see hexadecimal. Hexadecimal is also same thing actually. So I take 123 decimal value. Now let us go with the hexadecimal. I want to know the hexadecimal actually. So how we will do? So hexadecimal, the same thing, multiply by 16. So I take this one, and 6, 16 5 ja, 16 6 ja 96, 16 7 ja 112. So 16 7 ja 112, 112, and 11. 11 means B. So hexadecimal, if you take actually, so decimal, you know that one octal values, like 0 to 7, 0 to 7, because including the 0, and decimal you anyway will know that one 0 to 9 including 0, that's what 10 numbers actually. So octal is 8, so that's what 0 to 7, since you are including that, it will become, uh, yeah, so up to 7. Now hexadecimal, if you take 16, so since it is 16, first 0 to 10, it will be 0 to 9, it will be 10 numbers. Then you have A, B, C, D, E, F actually. So that's what it will be represented with the hexadecimal. So this is 10, 11, 12, 13, 14, 15, 16. So here, like 11, A is 10, B is 11 actually. So the C is 12, like that in the decimal. So that's what this particular hexadecimal values. Now you have 7B, which is nothing but hexadecimal value actually. 7B is a hexadecimal value. So 123 decimal, which is nothing but 7B in the hexadecimal. Okay, so I am writing the radix instead of writing that down. Yeah, I am writing here because it is difficult to write in the this Word document. So now this is how you convert that. Now let us take hexadecimal to decimal. So let us check hexadecimal to decimal. Same as this, you need to multiply by 16 actually. So I have 7, and then I need to take 16 to the power 0. So since we have two digits only, this is to the power of 0 to the power of 1. So same thing. So I will say this is not power, this is only the multiplication, and I take b into 16 power 0 actually. So 16 power 0 is uh, like 7 into 16, which is nothing but 112, and b is 11. So 16 power 0 is 1, so 1 into 11 will be 1. So this one will become 123. So this is how we will convert from hexadecimal to decimal. So we have seen decimal to hexadecimal, hexadecimal to decimal, and octal like this. So once we see the conversion, then we will check on the bitwise operator. So let us now try this one in the program actually. So let us try this. Now let me open a terminal. Okay, now I take v1 equal to 123. I want to print this one in the decimal, octal, and hexadecimal. How you will use? Better use this particular printf format actually. So that command, you can refer the Linux basics, what the details of the printf. So I want to display the decimal. It will be D, octal will be O, and then hexadecimal will be X. Small x, capital X, like no, the difference is small x means if it is ABCDs are there, it will be displayed in small letters. Otherwise, it is in the capital letters. Now let us try $v1, $v1, $v1. So if you see this one, 173, 123, 7b. Maybe I will write this one capital X, right? So it will be in the capital letters actually. So how you have converted this one like this. Now let us assume I take B1 is whatever 0, 1, 2, 3 something. Let us take the same octal actually 07173. So if you have the, if you now start with number, any number with 0, this is treated as octal number actually. So now let us do this, then you can see the same output of course. Now if I say hexadecimal, like I want to check with the 7b actually. Okay, so I take 7b because I want to reverse check that one. That's what I have taken the same numbers actually. So if you see this one, 173, 123, 7b. So it is like that. So if you are representing with nothing, it is a decimal number. If you are prepending this one with 0, it is a octal, and it is prepending with 0x, it is hexadecimal actually. So this is the how the number conversions and all. Of course you can explore with other numbers, and you know the conversions, and then you can explore on the other numbers. Now let us check on the bitwise operator. So as we said, bit actually, so you whatever you are representing the value, it is not in the bit, it is in the like decimal format. It is nothing but you need to convert into the binary. So that is the bitwise actually. So that's what like you will be converting into the binary. You know how to convert to the binary, simple. So decimal to binary, you will divide by 2. So that is the how you will do actually, that then you will get a bits. Okay, so that is the bitwise programming. So let us now try what is r and all. Let me insert a table, insert table. It's okay. Columns, I need columns for 2 values, and then the 4 for that, and rows I need like 5. 5 is enough, right? 4 and 5, yes. So now let us assume what is this. I say bit 1, okay, bit 2, then this is or operation, this is and operation, this is exclusive or operation, this is negation. So let us, if you take this one 0 0, these are bits actually. So we will take these bits, then we will try to see, and then 1 0, and then 1 1. So now if you see this one, 0 0 will be 0, and then 0, oh, sorry, this is R operation, so it will be 1 1. This is the truth table of the bitwise operators. So 0 0 0 and 1. And if this for and, both should be 1 actually. Exclusive or either 1 should be or actually. So that's what, for this it will be 1 1, and then for this particular one it will be 0, because both are like both are ones, so it will be 0. So what I'm trying is b1 or b2, right? So b, to be precise, like b1 and b2. Now b1 exclusive or b2. This one negation of b1 we will take, so this one will be the 1 1, and then of course this one will be the 0. Of course this will be again 1, this will be 0. So since it is repeated, so I just say negation of b1 is this one. So now let us take the value actually. So we will take the value as something like this. I will take small value so that you will be uh, we will be you will be comfortable. Okay, so I take 0 0 0 0 1 1 0 0 something. I need 1. Okay, I will take like this actually. So now if you take this particular value, this is nothing but 11 in the decimal format, 11 in decimal. Okay, so if you are not writing any radix, it is decimal. And then this is uh, 1 2 4 8 12 13 actually. This is again the decimal. So 1248. Yeah, so you know that one decimal to binary conversion, you need to multiply by 2. Like in what we did, multiply by 8 16. The same thing you need to multiply by 2 actually. Okay, so 1 into 2 power 0 1 2. So I will just take one value and tell you. So 1 0 1 1. Okay, I am ignoring all zeros before. So now I am converting binary to uh, decimal actually. So now if I take our decimal to binary also, you can try, we'll see that. So this is 1 into 2 power 0, 1 into 2 power 0. This is this one will be 0 1 2 3 actually. So this one will be the 3 plus 0 into 2 2 power 2. So anything into 0 will be 0 only. So 1 into 2 power 1, 2 power 1 plus 1 into 2 power 0. Okay, so this one will be whatever 8 plus 0 plus 2 plus 1. So now it is become 11 actually. So same thing, you can convert the decimal to binary, same thing. So we will also cover this, because this we need 2 11. Okay, so this one 2 5 are 10, you have the remainder 1, and then again you divide by 2. So 2 2 is 4, remainder 1. You will repeat this one until you get a remainder 0 or less than 2. So 2 1 ja 2, and then the remainder is 0. So if you see this one from down to up actually, so this one will be 1 0 1 1, so which is binary. So same thing you can convert for the next number. So if you see this one or operation, so if I take whatever the v1 or v2, v1 or v2 will become like from right to left. So this is 1, this is 1 1 1 actually. Okay, so I have all ones, okay, which is nothing but 15. And v1 and v2, it will become like 1 and 1 will be 1. So all these are 4 zeros, so I will keep it like that. Maybe I will give a tab here. Okay, so that it will be aligned. And then and actually, so this one will be 1, this will be 0 0, then 1. So if I take this one, this will be 9 actually. Now v1 exclusive or v2. So if you take this, so I am doing the same bit actually. So this is 1 or 1, it will be 1, and 1 0 or 1 will be 1, 1 or 0 1, 1 1 1, 1 or 1 will be 1. In the end, 1 and 1 will be 1, 0 and 1 will be 0, 1 and 0 will be 0, and 1 and 1 will be 1. That's what I did. Now exclusive or, so 1 1 will become 0, 1 0 0 1 will become 1, 1 0 will become 1, 1 1 will be 0. So this one will become 6 actually. So this is bitwise whatever operations. So now if you see negation of v1, now this is little strange, little different. So this negation of v1, so v1 is 0 0 like this. So I have 1 1 0 1 1 1 1 0 1 0 0 actually. So this is the negation of v1. But how you will represent this one in the decimal format actually? So decimal format, if you want to represent in the decimal format, okay, so 1 1 0 1 0 0. So this one, if you want to like if it is msb bit is 1 actually, if msb is 1, it is negative number actually. So then that is treated as negative number. So if it is negative number, you need to do 2's complement. So 2's complement you need to do. If you want to do 2's complement, you need to do 1's complement plus 1. Okay, you need to add plus 1 to this binary after making the 1's complement. What is 1's complement? You know, 1's complement is nothing but a negation, means the zeros will become 1, ones will become 0. So now if I take like the same format, okay, so the same number I will take. Yeah, so this may be, if you are very new, it will be little confusing, but just if you see this one, it will be easy only. Yes, so if you just try multiple times, it will be easy. So 1's complement I have like no 0 0 0 0, and then 1 0 1 1. So I am just making ones to zeros, zeros to 1, and now I am adding. Adding means plus I will do, and 1. So now if I okay, so now if I do this, okay, so why it is like no, it is doing the auto thing. So check. Okay, so if you see this, then if you add this one actually, so 1 plus 1 will become 1 0. So this one 0 and 1. So here again this 0 and 1 will come here. 1 1. I am just doing a addition actually. So I am adding to this number actually. So if I say 1 1, 1 plus 1 is 1 0. So you have 0 here, 1 remainder. Now 1 the like like 1 plus 1 is 1 0, so I have 0, and then the carry will be 1, so 1 plus 1 will be 1 0 again, so 0 here, again this is carry, so I will write this carry here. Okay, so if you put here, this is 1. Okay, so this is 1, so if I have 1 plus 1 0 1, so 1 0, so 0 here, 1 1, 1 here, 1 plus 1 is 1 0, so again here, so this one will be the 1, and then anyway 0, so this is no effect, so I will do like this. So if you see this number, and if you convert 1248 is 12 actually, so nothing but this is minus 12 value. So if you take whatever the value v1 which you have taken 11, it will become minus 12 actually. So this is the 2's complement form. Now let us check on the left shift and right shift operator actually. So once you see the left shift, right shift, then we will see the program, we will execute the program. Okay, so now let us check left shift and right shift. I take v1 is 10. Okay, so which is nothing but uh, I am writing only 4 bits, like 1010. Okay, so this is 10. Now if you have to left shift, maybe I will take, it is not convenient, let us take columns, let us take 8, and rows, uh, maybe we will use or not, but let's take 4. Okay, so now let us assume I have whatever 0 0 0 0 1 0 1 0, so this is 10 value actually, so 2 plus 8 10. Now you are doing a left shift actually, so if you are doing a left shift, I will write like v1 left shift 1. Okay, so here I am just instead of outside I am writing, so I am not sure, yeah, so if you have to adjust, maybe we need to write this one outside actually. Okay, it is difficult to write there, so I'm just writing here for our information. Maybe I will write another column. Mm, maybe, sorry, insert column, right? Okay, so maybe I will write this 0 here, and then this notation here actually. So now v1 less than v0 means what it will happen, like I will write another column also. Okay, so now if you take maybe here also I need to write another column. Okay, so now if you see this one, like left shift we are doing actually, so if you are doing a left shift, this bit will come to this actually, so this one, and then this bit will come here, like that each bit will move one position left. So and then you have whatever this particular one, which is nothing but this 0 actually, so which will be ignored, so this will be ignored, and this also will be ignored actually. Okay, so this one will become okay, this is the left shift, so left shift this will not come. Okay, so this one it will be filled by with 0 actually, so this one will be filled with 0, so you have a space, so it will be filled with 0. So here this 0 will come here, 1 will come here, like this, like this, and like this, like this, like this, like this. So if you take this particular value, this is 1 2 4 8 16, 16 plus 4 is 20 actually. So now again I do same thing, like v1, this particular, so if I take this one v1, now I will do v1 left shift 2 times actually, means what, you can do v1 left shift, already we left shifted this one time, so we will do another time, that will be enough actually. So I take 0 0 and then 1 0 1 0 0, and this one 0 will be filled, and then if you take this particular one, so it will become 40 actually. So if you see this one, 1 2 4 8 16, then 1 this is 1 2 4 8, so this is 8 16 32, 32 plus 8 is 40 actually, so that's what it is become. Now if you take the same v1 right shift 1, so I am doing right shift actually. Okay, so if you take this one, this is ignored. Okay, this particular value will be ignored, and if you this one v1 left shift 2, the same v1 you can take and you can do shift two times, or already we left shifted one time and we can do another time. So it is up to you how you are convenient for that. So now this 0 will come here, right shift we are doing actually. So v1 we are doing, so here 0 and this also 0, now 1, this one will be 0, this one will be 1, this one will be 0 actually. So this is whatever the v right shift. So if you take this value, like it has become 10. Okay, so that has become 10. Now like let us assume I take whatever the v1 right shift 2. Okay, so if you take this one, this particular 0 0 0 and this also 0, this 1 0 and then this 1 actually. So this is which is ignored. Okay, so ignored in this particular one, because like it will be out of that 8 bits actually. So if you take this one, 1 2 4 8, so this one will become v1 right shift 1 will become like 1 2 4 8, 8 plus 2 is 10 actually. Okay, so no no, so this is ignored, right? 101, this one will be 5 only, so sorry. So this you should not count actually. So this is 1 2 4, so this one will be 5 actually. And then v1 right shift 2, it will become like this is ignored, so this one will become 2. So whenever you are doing left shift n number of times, it is very simple formula, v1 into 2 power n times actually. So this is like this we need to do. So v1 is 10, v1 is 1 whatever 10 in our case. And if we are doing v1 left shift 2, so what we will be doing, 2 into nothing but 2 into like sorry 10, right? So 10 into 2 power 2. So 2 power 2 is 4, 10 into 4 is 40 actually. So that's what it becomes. So if you are doing a v1 right shift n, then that one will become v1 divided by 2 power n, same thing but 2 power n. So if I take same v1 right equal to 10, v1 right shift 2 will become 10 divided by 2 into 2. So 2 into 2 is 4, and then 4 divided by 10 is whatever 2. So the fractional part is truncated. So if you have msb bit as 1, it will be fractional part will be truncated actually. So that's what how it will be doing. So let us now cross check in the program how you will be doing actually. So now we have seen whatever the and are the things. Now let us check on the execution. So now I take the same value. So whatever we have taken, first we see this. So v1 we have taken bitwise. Okay, so conversions anyway we have seen. Then now it is time for us to check on the these particular operations. So by this bitwise actually. So what we have taken, v1 equal to 11, v1 equal to 11. Okay, so these can be done. So as we have seen that one, these bitwise operators, any expression evaluation, we have three types as we have seen in the previous session. So expression and the let and then the double parenthesis method. With expression, you cannot do the bitwise operation. You can do only with let time, let and then the double parenthesis. So let us check on that. So first check with the let. So v1 is 11 and then v2 equal to 13. Oh, sorry. v1 is 11, v2 equal to 13. Okay, now let us check on the v1 v2. We want result and v1 or v2 actually, right? v1 or v2, maybe let us check with the double quotes. Not sure whether let us try. Okay, so syntax error. Okay, space we have given, no. Okay, so now just echo the result, then we can see that one will be the 15. Our operation will be whatever. Let us check the R, yes, 15. Now, and we will see I am using the same variable. You can make it different, 9, right? Result is 9, and then exclusive R, it will be 6. Exclusive R will be 6, right? Now we will see the negation actually. So negation of v1. Okay, so let v1 equal to same 11 only, right? Yeah, result is negation of v1. Now echo dollar result. it will be minus. So v1 is 11, right? Okay, so it will be minus 12. Yeah, so that's what we got actually. So v1, this one will be the minus 12. So that's what whatever we got. So this is through let actually. So the same thing, let us do with, okay, left shift and right shift also we will try. So now v1 equal to what is that we have taken, 10, right? We have taken v1 is 10. Okay, so now v1 equal to 10, uh, result 1 equal to, let us print two things actually. So then result 2 equal to v1 left shift 2. Now let us execute this result 1 and result 2. So you can see here 20 40. Now the same thing we will try, but with right shift. So v1 will put the same thing actually. So now if you just do this, then it will be 5 and 2. So you can explore more with more values and all. So for quick introduction and for saving some time, so I use it like this with small values, but you can explore with big values. Now let us do the same thing with uh, the double parenthesis method actually. So I have whatever the v1 equal to 10, 11, and v2 equal to 13, right? And yeah, so result is, yeah, you can do in the same thing, but still v1 are equal to v2 anyway. We will do like this then, because v1 v2 we are not changing, right? So here every time we are assigning that, but it is not needed actually. Only one time you can assign and you can change on the result actually. Okay, so but we have did like that, it's okay. So here we will do in it different. So echo whatever the 15, it will give you the 15 actually. So this is that expression we are doing with the double parenthesis method. So now if you see, this one will be the 9, and then we have the exclusive r, which nothing but 6. So because no need to initialize the same values over and over again actually. So that's what now I have to like this. Now v1 is anyway 11, so I have dollar negation of v1. So I take this one. Okay, so you can use the same variable also, that we will see in the next session actually. Okay, so this is how we will do uh, the what is this complement thing actually. Now we will check the left shift and right shift. So let us make v1 is 10, okay, and then result 1 equal to v1 left shift 1. Okay, so result 2 is v1 left shift 2. Then we can say echo result 1 and then result 2. So you can see here 20 40. Now we have v1 10. Let us do right shift, and let us print the same thing. So it will be 5 and 2. Okay, so we have seen whatever the bitwise operators, how you will execute with the let time double parenthesis method. You cannot do other than that method. So just we'll cross check this what we seen. Okay, so this is whatever the first conversions actually. So if you want to convert octal to octal, you know, octal to decimal multiply by 8, octal to hexadecimal, you can do both the ways actually. So I have just written that, you can explore more on this. And decimal to octal, same, whatever divide by 8, this one decimal to hexadecimal divide by 16, like that. And this one decimal to binary, it is just you need to modify by 2 actually. And then like multiplication by 2 from binary to decimal, that we have seen in the samples. So here it is how we have represented. So we have already executed, you can explore more on that. So this is whatever the bitwise operator and or not, and I have given the bits what we have seen, and we have taken some values and then we have executed directly. We have executed instead of result, that also you can do. So but even though that is not that right way, because in real project you never use echo actually. Okay, so okay, so but here for your testing purpose you can do directly, you did echo actually. Okay, now the same thing with the let. So earlier case this was with the double parenthesis, and then this is for the with let actually, let. So here let whatever you need to give in the double quotes. Of course, if you don't give in double quotes, it will not work, because it will treat this is this is whatever the here document and all that strings meta character, so it may not work. So you need to be doing this. So next case, we will see the next thing, augmented addition and all. So this is for the bitwise operator. I hope you learned something from the session. Please explore more to know more about it. Thanks for listening. We'll see you in the next session. Bye for now.